This video is focusing on AS statistics hypothesis testing, the examples for critical regions. So in this example, we've been given a binomial distribution where n is fixed at 6, and the probability that we are looking at is 0.35. We've been asked to use a 5% level of significance to find the critical region for this test. Notice that we're dealing with a one-tailed test because we have got probability is greater than 0.35. In order to do this question, I think it's a good idea to get into the habit of considering that expected value that I mentioned in the last video. So if we just consider the expected value, because if you're doing this on your calculator, you need to know where that peak is in order to be able to put the values into the list. So the expected value here is calculated by doing 0.35 times 6, which is giving us a value of 2.1. So if you're going to use your calculator, you're in binomial CD. On the list, you want to start after 2. So you're going to start at 3 in terms of putting the values in. So you might consider putting into the list section 3, 4, 5, 6. And then I'm going to do this by using the tables. So if I just scroll down, and we're going to split the screen so that we can see the table here. So I am on n equals 6, and my probability is 0.35. So that's this section here. And I want to look up the top tail, remembering that I'm looking for probabilities where it is greater than or equal to, and therefore it's going to be one more than the number that I'm using here. So if we consider these numbers here, so just looking at that one, and I'm going to look at that one. It's a good practice when you're doing an exam question, if you're going less than 5%, to write down the values that would give you more than 5% and less than 5%, rather than just writing down one thing. So we're looking at the probability that x is greater than or equal to 5, which would use 1 minus 4 on here. So that's that value there, 0.9777. So that is giving me 0.0223, which is less than 5%. Looking at the other one that I've highlighted, so that's probability x is greater than or equal to 4, which is equal to 1 minus 0.8826, which is equal to 0.1174, which is obviously greater than 5%. That sort of working out shows that you are considering that significance level and looking either side of it. So it is good practice to do it. But in terms of the one that's satisfying our conditions, we're going to look at that one there. So the critical region, therefore your critical region is x is greater than or equal to 5. The significance level for this, so if you were asked to find the actual significance level, would be this probability here. So we'd get 2.23% in terms of our significance level. That's just using that value on there. If you're doing this on your calculator, it might be worth just pausing the video here, going to binomial CD and seeing if you can get this list up. When n equals 6, it wouldn't take your calculator too long to do 0, 1, 2, 3, 4, 5 and put that into your calculator. Obviously 6, if you put that in there on a cumulative distribution, you would get 1, so you don't need to bother with that top one. But just be aware that as n gets bigger, your calculator, it's going to take too long to put the whole table in. So you do really want to be considering which values to put in, as I suggested, because the significance, the expected value here is 2.1. I would put 3, 4, 5 into my calculator. I wouldn't go anywhere less than there. Moving on then, if we look at the next section, so this is for a two-tailed test. There are 2 critical regions, one at either end of the distribution. So what you have to do is you have to halve that significance level, which is the same as what we were doing when we dealt with two-tailed tests previously. In terms of the diagram, you would have some small probabilities at that end leading to a peak, and then some small ones here. So we've got 2 critical regions that we are dealing with. So in terms of the notation, we would be using union if we were writing in set notation, which is how we're going to write this down. When we're doing any distribution question, it is really good practice to define what X is if it isn't given in the question. So here we've got information on 30% of customers who buy train tickets in a station buy them for a single journey. A new manager suspects that there has been a change in the proportion of customers who are buying the tickets for a single journey. So X is measuring the number of tickets bought for a single journey. That will help with your conclusions when you write, because hypothesis testing, we have to write conclusions. So the number of tickets bought for a single journey. Stating the distribution then, we've got X squiggly line B, N is 20, and we have P is the probability. We need to state our null hypothesis. So H0, P is equal to 30%. So that has to be the information that you are given in the question, and that, so your null hypothesis has to be equal to something. So you have to take the information in the question, and that's what we're seeing if it's working or not. Because there's been a change in the proportion of customers, I don't know whether we're expecting an increase or a decrease, and this is what makes it a two-tailed test. So that word change, the reason I highlighted it as I was reading it out, is that's what's going to make me think two-tailed test when I'm doing this. In terms of the expected value, so if we're doing the expected value, we've got 20 times 0.3, which is equal to 6. So that'll just give you a little bit of guidance. So you can see this distribution is skewed. So if you've got 20, the highest point, so the peak of it is to the left of the halfway mark. So looking on the table, so if we come back to the tables, because this probability of 0.3 is one that's given, I need N is 20. So I'm just going to scroll down. This is in the formula book. It's also at the back of the textbook, if you want to look it up there. And we've got 0.3, which is this column here. And I'm in N equals 20, so I need to be in this column here. Okay. So we're looking for a two-tailed test. That means I need to consider both ends of the distribution. So we've got probability that X is less than or equal to X1, X1 being the value I need to find, and that has to be less than 0.05. Our significance level in the question that we were given was 10%, and it tells us that we're looking for less than 0.05. So if I'm doing that, if I come back to this distribution, I've lost where 0.3 is. Excellent, it's there. So we're looking down here until I get less than 0.05. So that's going to be this one here. So I've got that one. Doesn't want to highlight. And then, like I said before, I think it's good practice to go for both the one that's above. It's not highlighting, but you can read that off. So we've got probability X is less than or equal to 2. Is equal to 0.0355, and the probability that X is less than or equal to 3 is equal to 0.1071. That one's less than 5%, that one's greater than 5%, so that means I am going to go for that one and not take that one. The bottom tail is easier because you can literally just read it off the table because it's already been added up for you. In terms of doing the top tail, then we need to consider 1 minus these values. So we're looking at that one and that one. So 0.8867 is reading off when X is equal to 8. So coming back over here, run out of space. So where we've got less than or equal to 8, that's going to be greater than or equal to 9. 1 minus that probability of 0.8867. Which is 0.1133. And then your next one to check is greater than or equal to 10. which is 0.9520, which is 0.048. So I'm going to take that one and not that one because 0.048 is less than 5%. Now it might be that if you write one down, you don't have to just do 2, you could do 3 or 4 if you end up calculating right. It doesn't matter. The point is you've got to be able to pick the right one. When it says in the question, you should state the probability of rejection in each tail, that's these probabilities. I've done that as I was answering the question. So that's these probabilities. So I have done that as I've been going through. If I was asked for the actual significant level here, I would just add these 2 probabilities together. So your actual significance level here is 0.0835. The critical region is x is less than or equal to 2 or x is greater than or equal to 10. So that would be my final answer for that critical region. If then the question went on to say that the manager noticed that 11 single tickets have been bought, because 11 lies within this critical region here, we would then say that we could reject the null hypothesis, and this suggests there has been a change in ticket sales. Just because the evidence would be that line in that top tail wouldn't lead me to say that the probability has increased, because this whole test was just about there being a change. So if we have evidence that it lies in the critical region, then we just say this suggests that there is a change to the probability. If the evidence was 8, then it's inside your acceptance, then you would say we're going to accept H0, or that there's not enough evidence to reject H0. Moving on. So the next example, we are going for n is 40. So in the tables, I need to go down to 40. And the probability that I'm dealing with is 0.4. So that's that one there. I'm working on that one there. Using the 2% level of significance. Now, you will find that most examples work at 5% level, and therefore it's easy to slip up when you get a question that's asking you about the 2% level of significance. So do be careful of that. Because we are on a 2-tail test, that means I'm going to be looking at 1% in each tail. So we need to focus on that. So part A, expected value is 40 times 0.4, which is 16. So this is very heavily skewed towards the bottom end. And therefore, if you are using your calculator, and you can see it just by looking on the table. So if we focus on the table, if you look at the bottom where I've got 32, 31, 30, it's already got probability of 1. Now that's because it's been rounded, because this table is working to 4 decimal places. I think your calculator will go into more detail than that. But that just shows that you don't want to be, if you're using your calculator, just putting in values of 30, 31 up to 40, because you would have to keep going. So do be aware, when you're using the list on your calculator, you are going to maybe have to come back out and try some different numbers, because you might get a little bit wrong. But using that 16, that's where the peak of the distribution is going to be in terms of the individual probabilities. Then you know that you kind of need to be working from that point upwards, and then from that point downwards. Again, at the bottom end, if we're looking up here, we've got lots of zeros for the first bit. And looking at your calculator, it does go into a little bit more detail than that. So going back to the question, I'm looking at 1% for each tail. So I want the probability that x is less than or equal to x1 to be less than 0.01. Looking down the table, we're coming up to this probability here. Doesn't want to highlight. There we are. Still doesn't want to highlight. I give up. So this probability here, which is 9, and then the one below it, which is 10. So if we've got probability that x is less than or equal to 9, is equal to 0.0156. And the probability that x is less than or equal to 8 is equal to 0.006. So that one is too big. So less than or equal to 9 is too big because we're at the 1% level. That one is smaller than 1%. So it is that one that I'm going to take. If we look at the top tail, so working on the other side, we want probability that x is greater than or equal to x2 to also be less than 0.01. So looking at the top tail, if we come down to here, looking at where it is 25 and 26 is where the overlap's going to be. So the probability that x is greater than or equal to 26 is equal to 1 minus 0.9988, which is equal to 0.0012, greater than 1%. The probability that x is greater than or equal to 27, 1 minus 0.9996, which is equal to 0.0004, which is less than 1%. So I'm going to take that one. So the critical region here, just notice that should say less than on that 8. So the critical region here is less than or equal to 8 or greater than or equal to 27. So we've got x is less than or equal to 8 or x is greater than or equal to 27. So that's the answer to part A. In order to do part B, all you need to do is add the two probabilities together. So I've got 0.0004 plus 0.006, which is equal to 0.64%. Okay, those questions, all of those questions you can do using the table. This last question, we cannot use a table, so we are going to have to use the list function on the calculator. The reason for that is that either n or the probability is not listed. In this case, that 0.7 is not listed, even though the n value is. So we're going to have to do it on calculator. So let's start off by defining the distribution. So we've got x is the number of seeds which germinates. And it has a binomial distribution with n10. Null hypothesis. Probability is equal to 0.7. The question, is this evidence at the 5% level an increase in the germination rate? So that tells us we're on a one-tailed test and that the word increase is telling us that we're expecting that probability to be more than 0.7. So we've got one-tailed from there. The expected value is 10 times 0.7, which is equal to 7. And like I said, when you're using the list on your calculator, it's a really good idea to do that because you don't want to be waiting for your calculator and messing around and wasting time, because it will take time to load up. So on my calculator, then on the list section, I would put 8, 9, and 10, pressing equals to enter it into the list. It will then give me the option to enter n and p. So for n, we put in 10. For p, we're putting 0.7. And when you press equals, your screen will probably go blank for a minute while it comes up with the probabilities. And then basically what it does is it gives you the table that I've just been looking at on the left-hand side of the screen. It just kind of zooms in on these values. So when we're doing the probability that x is greater than or equal to 9, that's using 8 on your calculator because that's less than or equal to 8 on your calculator. So I get 1 minus 0.8506, which is equal to 0.1494, which is greater than 5%. Ten. 1 minus 0.9717 is equal to 0.0283, which is less than 5%. So I am going to use the critical region of greater than or equal to 10. Because n is equal to 10, the critical region in this case is actually just x is equal to 10, because it can't go higher than 10 because it was fixed at 10. So that's a special case. So then going back to the question, we have been given this bit of evidence here. So it's telling us that 9 seeds germinate. Because 9 is outside the critical region, that tells us that we do not have enough evidence to reject H0. So we do not have enough evidence to reject H0. You have to put a conclusion on these questions in context. And I am running out of space at the bottom here, but we'll write it in anyway. So your conclusion that you would need to write is something along the lines of, there is not enough evidence of an increase in the germination rate. Go back to the question. So the question was, is this evidence an increase in the germination rate? So I'm using the vocabulary that's been given in the question in order to structure my final sentence. So there is not enough evidence of an increase. Make sure at this point you answer the question. Sometimes, this is my best handwriting this. There we go, almost. Probably can't read that. So there is not enough evidence of an increase in germination rate. Sometimes a question will say that a person, so they'll give a name, I don't know, Bob. So Bob feels that there is an increase. Is Bob correct? So make sure you're answering that question. So there is not enough evidence to suggest that Bob is correct if that's what the question was going about. So do go back to it, read the question when you write that conclusion. You need to practice this. So we've made a suggestion down here on what questions you can do from the Edexcel textbook. So doing exercise 7B, questions 1, 3, 5 and 7 would help you practice it. But if you go back to some of the other exercises or do the mixed exercise within chapter 7 of the textbook, it will talk about critical regions quite a lot. Because like I said, all questions can be answered in this way. So it is worth practicing the critical regions method. And then the other method is just slightly faster, the one that we've already looked at. So if you understand both of them, then in an exam situation, you do have an option of doing that. But otherwise, I'd just stick with this one method.